Today we're exploring 10 insane dark matter discoveries. Giant leaps within astronomy furthers our understanding of the universe and the secrets it holds. But it has also left many mysteries behind waiting for new generations of scientists to solve. What insane things have been discovered about one of the most popular mysteries of our universe? Number 1. Is dark matter stronger than the current models predict? New images from the Hubble Space Telescope showed the light from distant galaxies having much more gravitational lensing than theory says there should be. Gravitational lensing is the phenomenon in which light from distant space becomes bent in arcs and circles as it passes through large clusters of dark matter. Data collected from Hubble and studied in Europe showed that the gravitational lensing on light coming from very distant galaxy clusters was much stronger than the scientists anticipated based on simulations they had run. The strength of dark matter's gravity needed to be 10 times higher than they thought it should be in order to account for the level of lensing that Hubble recorded. Could dark matter be stronger than we think, or is something else going on to cause this effect? Number 2. Could ordinary matter have turned into dark matter during the superhot and violent time of the early universe? A new theory is looking into the possibility that the domination of dark matter over regular matter in today's universe was caused when dark matter particles started turning ordinary particles into dark matter. This theory shows that when ordinary particles collide with dark matter particles, they can be transformed into dark matter under the correct conditions. It goes on to explain that the rapid expansion of the early universe is what kept dark matter from transforming all of the regular matter and allowed the universe to expand and evolve into where we live today. Number 3. Could dark matter behave differently than current models expect? A new idea about dark matter was just tested as a possibility as to how these galaxies exist without dark matter. Unlike the prevailing belief of dark matter known as cold dark matter, believes that dark matter only interacts through the force of gravity. But this new theory, known as self-interacting dark matter or SIDM, posits that dark matter strongly interacts with itself. New simulations have shown that with the SIDM understanding of dark matter, the halos of dark matter within the galactic cores of galaxies can be stripped away by dark matter masses that exist in other galaxies. This could give us a clear answer as to how these galaxies came to exist without dark matter, or may cross another theory off the list of possibilities. Number 4. Dark matter may decay, giving off powerful radiation as a byproduct. A new look at dark matter might lead scientists to uncovering the answer to a mystery that's been around for decades. Gamma rays are the most powerful form of radiation that we have found in the universe, and can only be created through powerful events such as supernovas and a black hole feeding on matter. Astronomers regularly pick up weak gamma radiation in the background that must be filtered out when taking readings of the cosmos. This radiation has been dubbed the unresolved gamma ray background, and there have been many attempts at finding the source of these background gamma rays, but so far, scientists have not been able to find it. But new research into dark matter has yielded results that show it can decay much like ordinary matter, just at a much slower pace, giving off a good amount of gamma radiation in the process. It just so happens that the regions of space where these background gamma rays can be found have a large concentration of galaxies, which in turn means a large concentration of dark matter. Could the decay of this dark matter be the source of the unresolved gamma ray background? And what will it take to allow astronomers to confirm or contradict this theory? Number 5. A new way to find dark matter. There may be a new way that astronomers have discovered to detect the concentration of dark matter in different regions of the universe. The secret weapon to this new form of detection are exoplanets. A recent study on dark matter's effect on objects in the cosmos showed that exoplanets that are near enough to large clumps of dark matter, the planet's gravitational pull can capture dark matter particles and pull it into its core. When the dark matter reaches the core of the exoplanet, it will annihilate itself and release energy in the form of heat. The more dark matter that an exoplanet draws in, the hotter the planet will get. This new form of dark matter detection relies on using an infrared telescope to measure the temperatures of different exoplanets throughout the cosmos, and using that information to better map the dark matter out in space. Number 6. Galaxies have been found that have much less dark matter than the current theory should allow. Astronomers have found several galaxies with no detectable dark matter. This came as quite a shock to many due to dark matter playing a crucial role in how scientists understand the formation of galaxies to take place. The gravitational pull of the ordinary matter making up stars and gas within these galaxies is strong enough to allow these ultra-diffuse galaxies to remain intact. But astronomers are still trying to understand how these galaxies came to have no dark matter, whether they were able to form without it, or if the dark matter was somehow stripped from them and all we can see are the remnants of what was left. Could further study of these galaxies give a deeper insight into the nature of dark matter and its role throughout the cosmos? Number 7. A possible contender for what dark matter is: the axion. Over the years, there have been many possibilities for what dark matter is made up of. One particular particle that has been at the top of the list for some time, the axion, may have been detected by a team at the University of Tokyo. Axions are hypothetical particles that exist above the standard model, that are extremely light and energetic. The axions that may have been detected are thought to have come from the Sun and traveled into the large underground tank where special fluid was waiting to interact with these minuscule particles as they traveled through the Earth. While the team is not certain that what they detected was an axion, if they are able to prove that an axion was detected, we may be close to a possible answer as to what makes up the dark matter in our universe.